Hello. All right, guys. Ready to get started? Hello. Hello. Steve. All right. So if by now you guys don't have a beer in your hand, you're doing something wrong. So please go grab one. Who here is using Docker? Great. That's going to make my presentation way easier, I think. How many people here are using Consul? All right, so not that many. This is not a standard Docker, how to install Docker, how to run Docker presentation. I'm going to just explain how we evolved our deployment architecture. And why should you hear from a guy that works at a game company? The right answer to that is you shouldn't, but I'm Lucas Fontes. I'm a services team lead here at Uken Studios. You can find me on internet, Alex Fontes, in a bunch of places, Twitter. I post pictures of dogs all the time. I like to take a lot of screenshots. And here at Uken, we are primarily a Rails shop. So every single time we produce a new game, we have two components to that. One is the backend and also the front end. On the back end, we write most of that stuff in Rails or Go, depending on the day. And we use Unity 3D usually for our front end. So Rails is doing a bunch of APIs, Unity 3D consuming those APIs. We have a bunch of servers, around 150 most of the time. We can get it up to 300, depending on our data analytics guy when he goes crazy on Hadoop. And we are pretty big on services-oriented architecture using NSQ. If you don't know about NSQ, you should totally check that out as well. And there's someone at the door, which is not going to get in. All right, so about our evolution. We are a Rails shop. As most Rails shops, we started where everybody started. We started with Capistrano. So how does it work? We put together a list of servers, static list of servers, production, staging, and Capistrano will execute those commands that we tell Capistrano to execute in sequence and lockstep sequence, meaning if we have 10 servers and we want to run a command ls, it's going to run ls on 10 servers. Once that's done, we go to the next one, and so on. We're also handling HA proxy configuration via Chef. Every time we spin up a new server, Chef would compile a list of attributes. HA proxy would read that, put the configuration, and please, can someone get the door? And with this, we were kind of dynamically configuring our load balancer. We also had Snowflake servers, so we had to pick a few servers to run database operations, run cron tests, and things like that. So nothing too complicated, but this was our setup. And we had about 15 clusters running in this mode, and one big cluster of HA proxies handling requests for everything. Back then, we were with soft layer and bare metal, living the dream. We had a bunch of databases and web servers. In databases, we were focusing on CPU speed, memory, having fast disks. On the front end, we had a bunch of CPUs with just a bunch of network cards. Make sure that we can get all the throughput that we could. Every time you buy a server at soft layer, you get 5 terabytes transfer. When you buy 150 servers, you don't know what to do with that transfer, but you're paying for it. Also, we had a kind of a weird situation with upgrades. Every time we do an upgrade, we would have to time our upgrades with the monthly billing cycle, so we didn't pay for 2 servers in that month. This was a bit of a weird situation. And because we were service-oriented, we had to have 2 servers of pretty much everything. So we had a bunch of idle servers around. In order to solve this, we built something called PowerUp back in 2013. And this is pretty much our platform as a service inside Uken. we were using Heroku build packs, and you can actually find how we were doing it on GitHub. We had an orchestration system, and this is pretty much inside Uken. We're not publishing that one. And to run those slugs that we built with this Heroku build pack, we were using LXC directly or some Docker, depending here and there. Docker back then was in version 0.4, and it was a pain to use. So going with just LXC, which is the underlying Linux container that Docker uses, was actually easier back then. We also wrote our own load balancer, and we also published that on GitHub. And the only magic it was reading configuration from Redis to determine where to route HTTP requests. So we get a request from, let's say, titans.uken.com. We would have to send that to titans01.uken.com internally. And things were great. And this is how it looked like. We started scaling it up. This was solving our problem with idle hardware. We got about 7 applications running there, 13 host names, 22 servers. Developers had a fairly easy way to deploy applications. They could just grab the Git URL, do a Git push, and things would just work. In a graph here would show the number of requests on this application. This one was just setting it up, so not much in there. They also had a mini documentation there, knowing how to deploy something. And more importantly, they had a way to scale up or down their applications. On the operations side, as long as we had the capacity, they would be able to come in here, crank this up to as many workers as they wanted, and we would fulfill that request, making sure that instances would fall on different machines, just so we don't cause a situation where we have all the workers on a single node, and if that one crashes, we're back to 0. Then Amazon happened. So we might be one of the few companies that moved into Amazon. And I'm going to explain why. There's a reason, I think. So the soft layer move. The bad part about soft layer, on top of all the unused network, the provisioning time was pretty steep. And their virtual servers were just not there. Every time we asked them about how to get servers faster, how to get servers quicker, they would just point us to the cloud instances, and at that point, we just gave up. There was another thing creeping up around 2013 on soft layer. We had tons of outages, to the point that we would detect outages before even soft layer would. And we even got a few jokes from soft layer. We got to a point that we decided to just move everything to Amazon. We would actually save some money. We saved about $10,000, $15,000 moving into Amazon, which is unusual, but it happened in our case. We decided to cancel all our servers with soft layer. I told you I take screenshots. And we decided to move to Amazon. So how did we do it? This is a total separate presentation, but long story short, we cut everything for 4 hours, and we appear on the other side. Always remember to leave behind one IP. You will need it. All right, so we are on Amazon. What should we do? We had Capistrano, we had PowerUp. They were both running. We had systems running on both sides. On the Capistrano side, we knew how we worked. We had a static serverless. We just put a bunch of instances, the host name for instances there, get it deployed, things would work. But moving to Amazon introduced a bunch of other issues in terms of autoscaling. Now that we want to scale things automatically, get everything going easily, it turns out it's not that easy. You need to be aware that every time you start a deploy, a machine might get added in the middle of the deploy. So then you start worrying, all right, so I should just block the autoscaling from running. No problem. What if an instance dies mid-deploy? Well, no, you cannot run from that one. You can also just turn off autoscaling, which would prevent autoscaling from removing one, but they might still die. And because we were using Chef to configure HA proxy, we would have to trust our instances that every time they spin up, they would register themselves to Chef and unregister them from Chef when they go up and down. And again, it happens that the deregistration wasn't as optimal as we wanted. They were not registering themselves, mostly because Amazon was killing instances with a different signal, so it wouldn't execute all the scripts on power down. But not their fault, mostly ours. We moved this check to our monitoring system, and we moved on. Great. Back to Power Up. So we had build packs, we had scaling, we had dynamic load balancer. Things were just fine. But we also had really poor adoption from the company, mostly because you need to prepare your application to run with Heroku build packs, or you write your own build packs. Turns out that we were not doing either. It was just one extra step for developers to the point that it became a problem for us to develop. And on the operation side, we didn't have more idle hardware, so there was no point in having the system anymore. So Power Up slowly became a ghost town to the point that we killed it. So then we went back to the board. We started collecting all the requirements that we have. One thing that we knew for sure is we didn't want to get tied to Amazon. So don't come selling me Beanstalk. That's not going to happen. We knew that we want to deploy some sort of containers or packages, so RGZs, things that we would be able to move from one machine to another without a problem. We knew that we needed some sort of dynamic load balancing, so either HA proxy, Nginx, your homemade load balancer that works or sometimes doesn't. It should be fairly easy to troubleshoot, so we wanted to make this logged on every single step of the way, and we also want to deploy anything, not just Rails. These were all the operational requirements. So then we went back to developers asking what they want. And then we kind of hit a wall because it wasn't clear, developers, what did they want. From their standpoint, what they wanted was, I just want to press a button and get this thing deployed. I don't care how you guys do it, I just want it deployed. Talking a bit further, we actually figured out that, yeah, there's more to just a one-click deploy. We want to send some Slack notifications, which is our internal chat system. We want to close Jira tickets. We want to make sure that we are CDN friendly. And CDN friendly here, if you participated in the previous DevOps Toronto and you saw Hanny's presentation, that's what I'm talking about here. We didn't care about Bitbucket. We were totally fine with GitHub. And developers also wanted to run rake tasks and also SSH on production hosts to figure out if something is broken there. And then we took a look at what is out there just to figure out if someone had the same problems. We could have solved this with many different solutions. Pretty much anything in this list here. The only ones that we knew we wouldn't go for sure is these ones down there, mostly because they are all paid and they're just shims around weird stuff. If you deploy on Elastic Beanstalk and you want to deploy Rails, they give you Apache or they give you Nginx with Passenger and they force you to use a specific Ruby version. For sure you can do all your stuff, you can script a bunch of other stuff, but at that point, it's just for the lulz. We just want to do it ourselves. They all work, but they don't work the way we want. So then we set up a workflow that works a bit more like this. We wanted to get an application, build it, make sure we can run it, and once we are aware that once we can make sure we run the application, we release it. And it's a bit weird, but I'm going to go through the steps. For in the build phase, we wanted to give power to developers, so they need to control what they are running. In order to do this, we deploy with plain Docker files. So in our repos, we have one Docker file. Developers, they control this. They control what goes inside the build or not. From the operation side, as long as we get an image at the end, we kind of don't care. Where should we store this? Well, we should store this on a Docker registry because it already supports this. So do a Docker push, and you're done. Because our builds, every time we build something for staging, we cannot just take that and move to production. We should, but we cannot. We also append underline prod or staging to our images, to our image names, just to namespace that even further. I think you cannot use another slash in there because they kind of go with the same idea with as GitHub with a name and repo name. And for revisions, we just have the Git revision replicated on the other side. And if anyone from Uken can go get the door, please. Thanks. So the thing with the version is, every time you do a Docker pull, it will try to run the image name column latest. Because we were doing this, we had to move the latest pointer every time that we release. So something to keep in mind. When we want to run an image, we only run images that have been sealed. And the idea here is, if we were able to compile something to build an image, we are able to run it. We should be able to run it in pre-production, or we should be able to run it on post-production. If you jump on a session, you add a bunch of stuff, and you try to commit that back to Docker registry, we just don't allow you to do it. We run our own Docker registry as well. So this worked great. Now in the release phase, we had to upload this image to Docker registry, notify all the hosts so they know that there's a new release, and at that point, they just need to run a Docker pull and restart on all the hosts. So it seems fairly easy. But this is kind of too high level. Let's start to get a bit deeper in this thing. It also looks quite complicated. And this is where we get Consul in. So Consul gives us distributed quorum. We can set a bunch of key value pairs, and it will be replicated across our cluster. The other thing it does, every time one of these key value pairs changes, we get a notification on the host. So we can just wait for a change on Consul. As soon as it happens, we can do something, as long as we are watching for that change. It does have a DNS and HTTP API. DNS API is going to be important. Keep an eye for that. And it also handles service registration. So let's say we started our Consul cluster. We have a node namespace, which means these are our machines, and we have the service namespace, which are our services. So we can control both, but every time that we register something, we register on the service namespace, and we can query this via HTTP or DNS. In order to glue everything together, there's something called Consul templates. This will allow us to get information from Consul, keys or services, compile that into something that the application will understand, and restart the application. And this is an HA proxy example. So we are getting the max connection setting from a key value pair. We're iterating through all services that have a release app, and we get an output with the proper ports and everything, and this is ready to reload. So on the host, this becomes fairly simple. We have Consul template detecting changes. It runs the template. As soon as it executes a command, Docker will run a Docker pull. It runs the image. Consul picks up that image that just opened a port or something, and things are up. So now that I think of it, it's actually a bit complicated, yeah. For load balancing, we also got Nginx with OpenResty and Lua, which means we were able to configure our load balancer just using Lua scripts. And in here, we would use the Consul DNS API to determine which server to send a request to. Let's say we receive a request for titans.uken.com. We know that internally we should route that to titansproduction.service.consul. Consul will give us a list of all the hosts and all the ports that we need to send this request to. We pick one of them, and we just run a proxy pass on that target. So this is fairly straightforward for Nginx. We do have a sample configuration online, and it's on that gist, but you can have these slides later. And again, this all looks too complicated. Not really. If you think about it, on the build phase, we are doing a Docker file. We are using a Docker file, doing a Docker build. On the run phase, we have a Docker pull, followed by a Docker run. On the release phase, we push to the repo, and we set a value on Consul. That's all we had to do. We can script all of this to make things way easier, but still, at a really high level, that's what we need to achieve. On the ops provisioning side, we can provision front ends and load balancers just using EC2 snapshots, which is great. We can pretty much autoscale every single layer in our applications. Now, from the developer's perspective, they still wanted to deploy using a single click. They had their single click there. What we did is we installed something called Sensem by Zendesk. This allows us to put a list of commands in here that people can just press deploy, and we will run the commands that we determine. We can lock environments when after 6 p.m. or things like that. But at a high level, ops can come in here, configure all the scripts. Developers would come in here and press deploy. And this was pretty sweet. This has login, everything. So, all good. Let's get to some tricks then. Every time you configure a server, if you're running a server pointing your DNS to 8.8.8.8, every time you do that, God kills a kitten. So don't do it. You have one task tonight. Go home, get a server, run a local cache, pay me a beer later. In our case, we use something called unbound. And because Consul starts a DNS on a weird port, we chain the .consul domain to in the DNS resolver, so we can just run queries regularly. We don't need to specify custom DNS, and things just work. It facilitates a lot of development and also deployment. If you're deploying using Consul and relying on their DNS API for anything, you shouldn't use .consul anywhere other than your own infrastructure, meaning you shouldn't expose this to developers. For developers, what we expose is internal domain called Uken.int, and we CNAME to the console names, so everything is CNAMEd, and they don't need to know that we are using Consul or something different. On Docker, and here like dragons, we have 4 or 5 file system drivers. If you're using anything other than BTRF or device mapper, you're in trouble. AUFS has tons of issues with number of layers you can create. Back then it used to be 47, 42. They bumped to 127 now, but still, it's something that you're just gonna hit this limit at some point. And OverlayFS, I never heard of this thing before. Device mapper is the most stable one. BTRF is the fastest one. So what we use is BTRFS on our build machines because we want to get fast builds, and we use device mapper on our front ends. Consul has something really weird going on with standard out login. Every single container you run, all the container outputs, standard out, standard air, will be logged to a JSON file inside var lib containers. I don't know what happened there. So run a container for about 1 month, and you get a full disk. They fixed this last Thursday on 1.6, which is pretty good. And for now on, that's pretty great, yeah. And they fixed this on 1.6 last week, and we haven't switched yet. I'm about to try this tomorrow. Hemi, on your app. Container linking, just don't use it. So we don't use it for anything. I don't know why they keep pushing that thing. So what we do is we run with --net equals host. What this means is every single container that we start, they will share the same namespace as the host. So if you open port 80 on container A, you go on container B, you can access port 80. The trick here is you cannot bind port 80 on both containers. Pretty simple. And every time you run Docker build, you cannot mount any volumes on Docker build. But you can do a Docker run, mounting a volume, copy everything that you need inside your container, and do a Docker commit right after. So that's how we got around the situation, although we rolled back to just using Docker build because we want to stay within the sandbox. Don't use the Ubuntu-based image in our front ends or in your infrastructure in general. Subclass that, create your own shim. In our case, we use something called Uken base, and we move Uken base from Ubuntu Precise to Ubuntu Trusty, and everybody else gets the upgrade at that point. The other thing is, if you're using the public Docker repo, they allow clients to override versions that have been uploaded to the repo. So if somebody uploads, let's say, Super Redis version 1, and they upload a week later Super Redis version 1 again with a change that breaks your environment, you'll pick it up in your next build. So be aware of that. And also, there's no official way to pass parameters to Docker build commands. Not sure how many have tried this, but what we want to do is run Docker build passing what is the Git revision that we are building. So the way to get this going, you can run a local HTTP server, point an add command to that file. Docker will take care of handling the proper caching as long as the file MD5 didn't change. You're not breaking Docker caching by any chance, and you're getting to insert things inside the Docker build process. So this is pretty sweet. And also know how Docker files handle caching. This is fairly important in our case because we build a bunch of Rails applications. Every time you have an add command, Docker will do MD5 matching or some sort of hashing on the files that you're copying into the container. If those are different, then you're busting the cache from that point on. So in order to get around this, we first copy our gem files and gemfile.lock, run bundle install. If those two files didn't change, the following bundle install will not run because we also didn't change that. And if the application changed, then it doesn't matter. We don't get to run bundle install over and over again just because the application changed. And right, that's pretty much all I have, guys. And I'm uploading most of this code to Uken autoscaling, including the basic images, all our scripts, load balancer configuration. I'm also going to put this presentation up somewhere at some point, and you guys can follow me on Twitter's, internets, and all of that. Great. Any questions? Right.
All right. So you mentioned running an HTTP server to inject environment variables. That's a pretty awesome. So why not use Consul for that?
Great question. We want to use Consul, except that we have a few things we cannot insert at that point. For example, the SSH key. We don't want to have the SSH key like sitting in our environment ready for anybody to pick up. So we copy the SSH key in the build process to the container, run everything we need to run, and we have an onBuild command that removes that at the end.
Why did you pick Consul or not Zookeeper? What made you?
Okay, let's get ready. So, Zookeeper. I don't want to install JVM. I think that's step first one. We could have gone with etcd. In fact, we started our load balancer with etcd, and later on we changed to Redis because we noticed that etcd, it wouldn't support more than 2 weeks receiving heavy writes. This was back in 2013, early 2014. We could have gone with Zookeeper. We just didn't want to do all that work using a custom protocol, which Zookeeper has. But the concept of ephemeral sessions that Zookeeper has would have helped us significantly here. Just that we decided to go with something that we liked a bit more. Yes. Right, on the back.
Sorry, are you guys monitoring anything on the Docker level, like resources used per container and so forth? I know New Relic just came out last week with the meta. I haven't seen anything else.
Yes, so we are not monitoring anything other than the service itself. The other interesting thing is we are running a single process per Docker instance. So there's a kind of a debate on if you should run fat containers or just one process per container. We tried both. We tried run it to monitor processes inside the container and then go from there. The problem is if that process is not exposed in an HTTP port, there's no way to monitor that outside. So you could do that via mounting logs and things like that, but we decided to just monitor the application from the TCP standpoint. If the port is open, I'm going to send you requests.
Sorry, you said that you're doing one process per container, but you also said you're doing the SSH keys.
Yes. So SSH keys, we use SSH keys during the build process because we host a bunch. Yeah, to pull code from GitHub in our private repos.
sorry, last one. Is there any reconfiguration happening inside the containers while they're running? Or is it that any config change means that a new image has to be pushed and then redeployed with that time overhead?
Any config change is required to deploy. So the idea is we can move any config changes because we broke something and we want to roll back. Those are fairly fast. But if we're moving ahead, then we kind of have this extra work of recompiling a new image.
Are you mapping Docker containers to actual hosts? Like, do you have anything for automating that, or are you doing it manually?
Yeah, great question. So we use Ansible to set everything up. We moved away from Chef as well. And this is part of the struggle with the whole Docker thing plus Consul. You could get autoscaling going without all of this, but we decided to do it this way just so we get all the machines set up using Ansible, and we take a snapshot and go from there. So yes, we are using Ansible to determine which machine should run what initially. But once they are in there, we just snapshot it.
Yeah, for the network, I know you just get the host networking. You get to compare the host networking and over the
Yeah. So by doing --net equals host, it means that the containers will get the same IP as the host machine. And that means it's fairly easy to collide ports. We just make sure that we don't collide ports. At the end of the day, we are only running one container per machine, mostly because we don't want to get the benefits of multi-tenancy with Docker. We just want to deploy faster.
You looked at the networking stuff that they just showed a couple weeks ago?
Yes. So that adds about 300 milliseconds latency, and we're not going there yet. But if we were not on Amazon, then I wouldn't have to pay for the 300 milliseconds on Amazon, and it would make sense to go with that.
So does that mean you're going back to something?
I got one more question. So you mentioned before that you're using your HTTP server to serve up an environment variables file. So you don't keep any private information in your Consul key value store?
Yes. So we don't keep anything in there other than the version that we're running and which version a host should be running, because we can also do rolling deploys if we deploy to just one host. We should be using Consul for more stuff. We should be using Consul for database URLs, number of workers, just so we can change things on the container, reload the container without a full redeploy. It's just that we're not there yet. This is kind of the next step.
So what would be your reasoning for not putting any private information in Consul?
Mostly because we have a lot of people. And our developers, they have access to our infrastructure. So we have about 70 SSH keys that we need to be aware of.
Right.
Do you use Docker for databases too?
No, we do not use Docker for databases. And unless there's a really good reason for that, I wouldn't use it for databases. It's probably okay if you're mounting the data itself from a volume, but just for the sake of using Docker, I wouldn't use it. Yes. If you're running with the log thing, get that going really quick.
So I'm new to Docker. So you using one service per Docker instance, but are you using multiple Dockers on the virtual machines as well? Like, how do you determine that?
So we're just using one per machine.
So you're running really small machines than just regular?
Yes. Or really big machines with lots of unicorns, which they...
So the only point of Docker is really to make the configuration flow from the developer.
That's correct. The other thing that we get, because we are using just plain Docker files, we can run boot to Docker on developer machines and get everything that should happen on the server, on the deploy time, on their own machine. So testing is quite easy.
Have you got any automated testing in your workflow?
Sorry?
Have you got any automated testing running within your workflow?
No. I ran for 5 minutes on my laptop. It worked shipped. So. Are you hiring by any chance? Right. It's great, guys. Thanks a lot.
Is that your laptop? Yeah. Okay. Do you mind if I just hook URL on that?
No,
Or otherwise I can plug in and use mine.
No, it's okay, fine, because this one is streaming actually.
Oh, okay. Yeah. Sweet. Perfect. Cool. Sweet. And then how does it work with the remote? Can I use the clicker? Is that just like the right arrow key? Is that just the cursor? Pretty much. Okay. Yeah. Cool. Nice. And then where's the laser? That thing's badass. This guy. Okay. Beautiful. Thanks a lot. Awesome presentation. Yeah. Thanks a lot. Yeah. Like a lot of like interesting things resonate with kind of what I'm about to say. Nice. So yeah, cool. It's really cool to like hear like a very similar use case, but different perspective on some of the choices.
Yeah, we suffered a lot with the deployment system. So
Yeah, for sure. We came from like Capistrano background, like push base, stuff like that too. So interesting to see how yours evolved and
yeah,
good stuff.
went down a different direction, but
Yeah, totally.
yeah, so
Yeah, cool. You guys use Consul for business logic?
no, just purely for service.
Sweet.
Oh, then
Yeah.
beautiful. All right.
Sweet. You want to take a break or are they good to go?
I don't know. I think people would have finished if they wanted to take a break. So you have 30 seconds to grab a beer if you want one. But I'm going to introduce Adam from Universe. He's here to talk about, I'm imagining AWS, Docker, and Chef. I'm just going to take a wild guess.
Something like that.
Something like that. All right. I'll give him, you can have a 10-second countdown.
Cool.
I'm not going to count. Just everyone count in their heads.
Do it. You want to wait?
Cool, I guess I'll start. Hey everyone, my name is Meghji. I'm from Universe. Thanks so much for coming and listening. I'm super stoked about all of this stuff, DevOps, the stuff that we've been doing at Universe, the stuff that we kind of come up with. So at any point, like after this, feel free to hit me up if you have any questions. We'll do a Q&A thing. I've got a lot of slides here, so I'm just gonna like rip through them, try and cover as much ground as possible. You know, I'm a developer at heart, so I've estimated how long this should take, but I'm probably nowhere near gonna make my estimate. Cool, so here we go. I'm Meghji. I'm co-founder and CTO at Universe. Yeah, I'm passionate about like APIs, DevOps. I do JavaScript stuff. I'm also a DJ and beats. You can check out my website here. And yeah, Universe is a social marketplace for events. We're a Toronto-based startup. We have an office in SF. We've been around for 4 years. Selling tickets in production for 3. And we're a ticketing platform that enables event organizers to sell on their own web pages through some of our embedding technology, as well as through Universe channels like our website, mobile, etc. Our value proposition is that we allow you to sell more tickets through our platform through smart social stuff and various other channels, which help with cross-sale and blah, blah, blah. So today I want to talk about how we use AWS and Docker and Chef for what has become a pretty good like DevOps solution for us. It's kind of funny, we actually came from a similar background as what Lucas was describing before, where Amazon, Capistrano, and such. Now we're big fans of like microservice architectures. So as opposed to having one massive monolithic app, which naturally, like as a startup, you might start with a Rails app and add an API and other things to it. From day one, we really tried to keep like microservices in mind and communicating them across with REST and workers and that kind of thing. So yeah, you'll hear about how that works. And yeah, I hope to share some of the lessons that we've learned and inspire you, and hopefully people will take a couple gems from this, go home, hack on them, take them to work tomorrow. Who knows? If you take a couple things, I'll be totally thrilled, and that's kind of my goal, hopefully. Cool. So just a super quick overview of Universe tech stack to give some context to what I'm talking about. Again, microservices. So we've got a bunch of clients: JavaScript, iOS, Android, etc. Those communicate to a number of APIs, which internally hit other microservice APIs, which add business logic around databases and that sort of thing. So well, the reason that sort of like makes DevOps important is we're not afraid to choose the best language for any particular piece of our stack. So you'll see, like, for example, Rails, bare metal Ruby, Node, Python, various things, and then lots of databases. So and a lot of times, like, these microservices run slightly differently. You might set up a Rails server slightly differently from a Node one, from a Python one. And let's say you're a developer, you want to get involved in DevOps. It's kind of hard to just take that knowledge across microservices because you sort of have to like ramp up on how each of them are structured. That's not ideal. So what we tried to do is we use Docker containers to add a smart layer of abstraction around that, and hide the gory details so people can be familiar with working with the containers and some conventions that span different languages and frameworks and such. Op-wise, just given our use case with Universe, because we sell tickets online and sometimes these events are in high demand. It's like the food festival of the year or something. People calendarize tickets go on sale at a certain time. So just given our use case, you'll get like flash traffic surges, and that's something that's like common in the ticketing industry regardless of your scale. But we need to obviously try and make that work 100% of the time. It helps that we can scale our microservices independently. So let's say if one particular API is fielding a lot of work, we can scale that up. If a job queue gets backlogged, scale up the workers. So that really helps. So you're not just scaling up like a monolithic app. You can just surgically dial up what you need. And also because it's a microservice and things happen, if something goes down, you don't want that to like cascade across your whole stack. That would be horrible. So things generally need to like the queue might get backed up, and then when something's back online or Amazon's fixed their thing, that will flush, that sort of thing. So we try and keep things tolerating failure. And yeah, it's we run on Amazon. It's the cloud. Shit happens. You might get a noisy neighbor. You might get a stuck instance. You need to be able to recover from these things in a way that's not super painful. I mentioned I'm a DJ. I've had to like reboot instances while DJing on Serato, like in a new window. That's not fun. So autoscaling's helped automate the pain in that, and I'll talk about how that happens. Cool. So the first thing, when we went from all these microservices and all these different like servers that were handcrafted with lots of different conventions, the first thing we wanted to do was just standardize on switching everything to Docker and packaging that all up in containers. So I'm going to talk about a couple things that you might want to consider if you're seeking to do that in your business. So first off, yeah, it's nice launching a container when you boot an instance is nicer than having that instance run whatever is special running on its like the host VM. It's nice because you can run the same versions of things in development as you can on production. And we all use OS X to develop, so you might not actually have the same PDF library, graphics magic. Like these things were not always the same. So there were some issues that you could only reproduce on production because it's running on Ubuntu with certain libraries that in development you didn't have. And that's just annoying. So now at least when you run a container, you can reproduce that locally. Similarly, you can make changes and you can stage them and you can roll back and you can test them in development. So it generally helps like organize things and standardize stuff. Also things like like Apple Passbook certificates, those things can get added to the Docker file. So you don't have to worry about like forgetting to update a server and then it works like some of the time and not always. Classification of issues goes away once you've standardized on that. Cool. So the first step was just getting the app ready and all the various microservices ready to be Dockerized. And there's a number of things that were valuable lessons learned in that process. First off, all app servers should be ephemeral. There shouldn't be anything on disk that anything stateful that you might need in order for things to succeed. you should be able to, clone a template, spin something up, spin it down, whatever, and it'll perform 100% of what it needs to do. That was pretty important. Secondly, separating your app servers from your databases. There's a tendency you might spin up just one instance of something, you run Redis locally or Memcache locally or something locally, and it's just conveniently connecting to a local socket or something. That doesn't really work in the case of a container if you want to be able to have things load balanced and scaled out. Because obviously you can't have n instances of Redis and this and that if it's backing a queue or something. So the first thing, just get all that stuff off of your app servers. For us, we moved it to, generally speaking, just hosted Amazon RDS for Postgres. We use a hosted Mongo thing, hosted Redis at Redis Labs, that sort of thing. So we moved all that off, and then the app servers were single purpose. In terms of, some people have different opinions on this. Some people use environment variables to pass in sensitive keys. We used encrypted client secrets. So that was better than having plain text secrets available. So that was definitely helpful. And yeah, Lucas touched on this in the last presentation too. I mean, if you find that you have 70 different people who need to hop onto a server and it's a nightmare keeping all the keys in sync, you can use a jump server. Just have one box which people will SSH through when they're getting to the other machines. That way you can just maintain authorization keys on one box. That will help you out. Also, in the process we SSL'd everything, and it just got expensive and annoying to be buying new SSL certificates all the time. So just if you're a startup and you're budget conscious, just take the plunge, drop the $200 or whatever on the wildcard SSL, and it's super easy, especially if you're using ELB. Cool. A lot of what I just talked about is actually summarized in the 12-factor app. So if you guys are familiar with the 12-factor app, check this out. Really covers 90% of that, and it's a great start. And then of course you can tailor the remaining long tail of things as you need. So originally, yeah, we tried to do the whole fat container thing. The belief being that the container is 100% fully self-sufficient, fully baked. You just run the container even with no parameters, just Docker run, web production or something, and it will just fully run everything with all the assets, all the dependencies, everything that it needs, and there would be a version 1 of these per git commit. That's a cool idea in theory, but we also use Circle CI, and we want to hook this into that, and so it didn't really work that well, just given that the CI is fully ephemeral as well, so we didn't have it wasn't incrementally building images, it was just doing a full blown pulling everything, setting everything up. Rails assets precompile takes forever, 5 minutes, if it's not incremental. So that added more time. The whole thing ended up if the test suite took 2 minutes to run, it took 22 minutes to actually have the image fully pushed up to our Docker repo, and that just wasn't practical. Also, they're huge, so we had a lot of we might push 20 commits a day. You don't want 20 gigs of orphan image files and stuff. So yeah, that didn't really work out too well. Instead, what we decided to do was take the things that we update frequently, aka app level stuff, out of the container, and then just make sure that essentially what runs is just the web server process or what it takes to run the jobs, and don't bundle in things don't run bundler all the time, don't run assets precompile every time. Just sync that, just run it once, run it incrementally, and sync it to the host VM, and then use a shared volume to mount that in. So that results in you only do Docker build really when you change things like nginx configs, or you need to change some property of the container, but that doesn't really have to happen very often, maybe once every week or 2 or 3. And then you can just quickly update the contents of the file system on the host VMs. So that ended up being way faster, way more practical, way more economical for us. And in addition, at first we had a gigantic Docker file. We just take the base Ubuntu and build every possible thing, including compiling Ruby, lots of stuff. That took forever to build. Instead, you can actually shortcut a lot of that, and you can leverage just general practices in the community by using the the Fusion base image. So it's based on Ubuntu 14.04, which is nice, but it does things it runs an init process, so you're not actually going to be running a Docker command as PID #1, which in the Unix world is reserved for your init system. And an actual init system will run, and then it can gracefully shut down other things running in the container. So it's kind of a workaround to a Docker design issue. And also, if there's ever any open issues, issues with apt or etc hosts, etc., this thing will have, like just short-term workarounds until Docker will, commit that into like the next version. Also includes things like syslog, cron, things that you might find helpful if you're operating the container. So if you're running a web server or anything in like Ruby, Python, Node, one thing I would suggest looking at too is the Fusion passenger servers. You don't even need to run the passenger portion of it. You don't even need to run the Nginx portion of it, but it comes with various versions of Ruby, JRuby, Python, Node baked in. So it's nice. It removes like a lot of just boilerplate stuff from your image, and you just sort of cherry pick by uncommenting things, what you want to enable. And we found that actually like really sped stuff up and just made the Docker files a lot easier to manage. You shouldn't really need to worry about recompiling Ruby these days. Cool. So when you're actually running the containers, yeah, we did something similar to what Lucas describes about mounting the shared volumes in. So you can see, for example, when we run the actual containers, we name it. We mount with the -v thing, the host path to the container, and we set the the app root, and we expose port 80. So port 80 in the container ends up mapping to port 80 on the host VM, and then ELB will listen for that. So various other like health checks will kick in. So let's say we're running this app server now, and we want to push some new code up. One thing that we didn't want to do was especially if you have the fat container as describing before, you'd have to like stop the Docker container and restart it. We want to do something a little more graceful. And since in our thin container model we've got everything stored on the host file system, the deploy script, which I'll walk through in a minute, will update all of that. But now we need to tell the app server that something changed, and it should actually go and reload the app dependencies, the app server logic, blah blah blah, and then phase in like the connections without dropping anything, etc. So yeah, if you're running a web server, it should just do some kind of rolling, like reload the app and do a rolling restart. If you're running job workers, you don't just want to stop the container, because that might actually terminate jobs which are running in process. It might corrupt stuff, clobber things, result in bad scenarios, whatever. Instead, it's better if you can signal to it gracefully that it should start like winding down, and once it's wound down, like then reload. And if that for some reason times out, then you need to be a little more forceful by telling it to kill itself. And then if that doesn't work, you just gotta like slay the thing with the sig kill. Anyway, so reload wise, so if you use that passenger image I was talking about before, you actually get a lot of that for free. They've solved it. So if you're a cool passenger, then you get that one for free. It's kind of nice. I would start there, and if you need to use something else, then you can get your hands dirty with it. Yeah, so let's say you need to run Puma, then you can use like the Puma control. You just do a Docker exec. So in the running container, you just say bundled exec Puma CTL reload. That will instigate Puma's phased restart process. So we do that for the web servers that are running Puma, for example. But let's say you're just running like a node, like running node on a JavaScript file, for Q, or you're running another process like Sidekiq in Ruby. So in that case, yeah, you need to do the whole sig term, sig int, sig kill, like graceful restart dance I was talking about. And one thing that will facilitate that is a gem called rerun. So you just do gem install rerun. That thing, it's like guard. It will watch your file system, and if anything changes, it will initiate this dance. So that was one way that we were able to gracefully reload stuff without killing containers and possibly risking like aborting jobs and stuff. So that kind of gives you like a high level view of the Docker portion. I'm gonna now move into how that fits into the sort of overall architecture. So for those of you that don't know about AWS autoscaling, I'm just gonna give you like a 10-second crash course in it. And autoscaling is available like in EC2. It's one of the options under the EC2 menu. The autoscaling groups consist of a couple things. CloudWatch events, which are events based on metrics which get fired when stuff happens on your boxes or your network, that sort of thing. An EC2 launch configuration. And an EC2 launch configuration is basically, when you're spinning up a new instance and you're clicking through that wizard, Ubuntu, instance type, etc. A launch configuration is like just a saved form version of that. So you'll fill it out once and then it gets saved. And then optionally, depending on like what kind of group you're running, for example, a web group, you might need that behind ELB. So autoscaling will know to associate that with the instances, and it will spin up like healthy instances as a result. So yeah, so in terms of the autoscaling group, the way that we've set it up is we have, let's say for each microservice, we set up one group per microservice per environment. That way we actually have like, for every microservice, we have a full staging set of everything and a full set of production stuff. We really try and keep staging and production as mirrored as possible. You know, if you load every microservice into one staging box, it's not really going to be a great representation of production because things are quite different in that architecture. Cool, yeah, so as I mentioned, it, you know, associates to your ELB. Also, you can say how, you know, big or small you want the cluster to be, so you don't go broke from this thing spinning up like a million different instances if you have a bug. Cool, yeah, and then the launch configuration. Oh yeah, also another important part, it stores the user data, which is a script that gets run when the instance is first booted. I'll show you what that looks like in a second. So yeah, when the instances get launched, they get launched in, you know, different availability zones. So it's nice if one zone goes down, if US East 1B goes down, it will spin up something in 1C, 1D, whatever, and it will just like heal itself. So that way, you know, you can tolerate some of the Amazon outages that happen, you know, once a year or something. We tag them with like instance tags, app and environment. That way we can discover them later. And yeah, and then basically this thing will just launch, run the Docker container, and has the application code on the file system. So ELB, this is where we do our SSL termination. Again, the wildcard circuit is super helpful here because you have, you know, n ELBs for every microservice. And you don't need that if you're just running like workers that are picking off a queue or something. So in terms of user data, you know, a lot of this is just, it's just boilerplate. It's not that long. It's about like 15 lines. And it just does 5 simple things. First off, it installs Chef on the new box. So the box spins up, puts Chef client on it. Secondly, it just writes the Chef config. So when the box loads, it knows that it's, you know, a web production box, box office service production box, etc. And then it installs AWS CLI so it can actually hit S3. Once it does that, then it hits S3 and downloads a couple private keys, which it needs to connect to our Chef server. And that's secured via IAM. So IAM, for those that don't know, it's basically like a way to declare that because this instance is launched with a certain role, we can just say that this S3 bucket, things of that role can read files from it. So that's how we pull down private keys. Now that the preconditions are met, we just run Chef client and it will connect to our Chef server, figure out the playbooks, determine what it needs to do, and then just starts like actually running through the Chef process. So what does that look like when, you know, we actually, if we zoom out and look at it, here's a sequence diagram that kind of shows you, you know, from a blank, well, from a CloudWatch alarm, so let's say an instance is unhealthy or something needs to scale, how does that actually go from that event all the way to accepting traffic and, you know, unhappy instance? So let's zoom in. The first thing, when the CloudWatch alarm fires and it needs to add a new instance, it spins up the box and it will tag it, boot it, and then it will run that user data that I just talked about. It will pull those keys from S3 and then connects to Chef. So on this slide we see, you know, basically what's happening in the Chef cookbooks. First off, you know, we have a brand new instance, so we want to make sure that it's actually secure. We're not launching some insecure accident waiting to happen. So the first thing, you know, upgrades itself, installs fail demand, paper trail for log aggregation, does everything that is consistent across all of our servers. And then it does a very similar thing to pull the Docker key so it can actually hit our Docker registration, Docker private repo. And then okay, so now at this point it's like ready to actually pull the app and get started. So it pulls the Docker image from the Docker private repo. It downloads the app from S3, it's tarball, extracts it. It sets up upstart, and then it actually like starts the service. So yeah, so in terms of like, yeah, the first cookbook, I mentioned that, you need Docker, the app server cookbook, and this is really like where a lot of the heavy lifting happens. And we actually use this cookbook for the deploys as well. So you know, you can fully repeat this process. It's idempotent. Essentially, this makes sure that the machine has the latest code and it's like fully able to do the work that it needs to do, and then, you know, you're good to go. So we don't have like a different setup for launching a new instance versus deploying to an existing instance. It's the same process and it runs regardless. Yeah, so basically once the service is launched, you know, start box ops production through upstart, the thing will become healthy. it'll start, responding to health checks on port 80 from ELB, and ELB will then detect that it's good to go, and it will just start routing traffic to it. If there's no ELB because it's processing jobs, the container will start up. It'll hit Redis or whatever your queue is backed on, SQS, whatever. Start picking off work, doing stuff, and it just chipping away at that backlog queue. Cool. So again, that's kind of what the process looks like. And when I talk about so deployments, right? So let's say we need to push the next version of the app up to this microservice. What happens when we run that? So essentially, it's this portion of it that just gets repeated. And because again, this will just download the new tarball, extract it, and then issue like the restart, reload commands, and it will just do work on the latest version of the code base. Yeah, it's nice. I mean, we initiate all of that. Like developers don't need to know how to initiate a deploy. Really, you just go to HitChat, and we have the Universe Snowman bot running Viewbot. You just say box office production deploy cap. That's legacy. There's no Capistrano here. And yeah, so in terms of that, the Universe bot will then run a deploy script that we wrote, which basically just does 4 things: builds the app tarball, pushes it to S3, kicks off that process we saw a second ago to sync everything, and then runs any migrations. So the build step, because we need to support different languages, this is where we start, digging into the depths of like Ruby versus Node versus etc. So if there's a gem file in the app, it knows obviously it needs to bundle stuff. So it bundles all of the gems into the tarball. It vendorizes them. We don't have them living on the host VM. Well, sorry, we do, but yeah, they get bundled into the app, which then gets synced. Same thing with assets. If there's assets to precompile, then it does that. And then if it's Node, it does an npm install through a makefile. This makefile make dist that will like compile CoffeeScript, etc. if that applies to you. So basically, it just introspects the directory and then figures out what it needs to run in order to get this thing built. So once it's built, tars it all up, excludes stuff that you don't want to sync, like logs, caches, big things, etc., and then puts it in S3. Now, the bucket in S3 again is secured with the IAM rule I talked about before. So only EC2 instances that were booted through this autoscaling setup that were associated to that role can actually pull these things down. Cool. So in terms of now we've got this like tarball up in S3, and we need to tell all the machines to fetch it and then apply it and then restart. So one of the problems we had, we're autoscaling and adding instances, but we don't necessarily know what their host names are, because that can change at any moment. So what we do is we use the tags that we set up before to look up all the instances for this particular tag, and then in this case we use Ansible just to do an ad hoc command just to tell everything to repull. So after hearing Lucas talk, like this could easily be replaced with Consul. You could do the Consul key value update dance to get that to trigger the whole chef script. That would work too. And it might even be cleaner because that way, you're not pushing the things, you're letting them pull for themselves. So, I'm inspired. Maybe I'll go try that tonight. Who knows? But then, yeah, the outcome is that this thing will run the chef process I showed you before, and it will, automatically pull itself, set itself up and reload. So now you can run, if there's any migrations, we just choose any random box in the cluster. We don't want to run migrations like, more than once. You only want to run them on one box. So if you have anything that you need to do in your deploy process that requires one machine, we just choose one, and we do a Docker exec telling it to, in this case, rake dmigrate, which will be familiar to people who use Rails. So we had to write a couple of tools that would help us, like pull up instances, pull up containers, because as I mentioned before, we don't know what the host names are. Not everyone wants to fish through EC2 like instance lists to figure out what the host names are. So we wrote a little shell script. Sadly, it's called ssh.sh, which is like a tongue twister, but whatever. You can just say like SSH web staging. This will put you into any of the web staging boxes. Then you can do stuff on the host VM if you need to. Yeah, so it's nice. Instead of like looking up the host names yourself, you just use the name tag and it will figure it all out for you. And it also uses the jump server too. So because no one can, from their developed machines, can access the real machines directly, this thing will also just, basically like tunnel through the jump server and put you on that other machine. So, let's say if somebody left the company or joined the company, you just need to change that one file, and then, they either have access or don't have access to everything beyond the jump server. So once you're in the server, I mean, you can run Docker exec on stuff, but you don't. Again, it's just another thing to remember if you're trying to like craft this, Docker command to actually open up the container. So we have attach, which basically uses the ssh.sh script, and then puts you right into the running container. So since we only run one container per instance, it's pretty easy to know what that is. So attach.sh just drops you right in. This is particularly useful if you want to do things like pull up an interactive Rails console, clear a cache, even if you just want to like poke and pry and do whatever you need to do. This will put you right into the working directory of the app with one command from your development machine. So how did this actually fare? Yeah, so far so good. I mean, what we've achieved so far is a consistent way to, take all of the different, disparate languages and frameworks and server configurations and, create one standard way in which everyone can interact with it, which is a lot nicer, makes a lot more sense. It's one thing to learn. Also, because this thing is self-provisioning and can heal itself, if a health check fails because a region's down or whatever, this thing will like spin up a replacement and it's all good. You don't have to stop DJing to fix a server. Yeah, the developers, again, they don't need to know about the gory details of, running, what it means to run Python and HA, this and that. And also, it's pretty easy to whip up a new one. So if you need to like add another one, there's lots of documentation because the conventions are established. So really adding like an additional Rails, microservice is pretty easy, and it doesn't take much to figure out how to do that. Also, as you've seen before with the SSH and attach scripts, you can write a script and then you get it for free across all the languages if it works according to the setup that we've created here. So yeah, of course, engineering is not without its trade-offs. Of course, one area of optimization here is cost. We weren't concerned about optimizing for cost immediately, and that's why we have lots of ELBs running. They're not that expensive, but I think they're like 10 or 15 bucks a month or something. But you could get that down, by making all traffic go to one ELB potentially, and have different HA proxy machines with maybe like we saw before, a Consul-based discovery thing, subdomain routing, health detection, that kind of thing. You could bake into that. So you could go from n ELBs down to one ELB just with some additional engineering. Another thing you could do, utilization, because we're only running one container per instance. There might be like additional CPU, RAM that's not being used, and yeah, I mean, there's stuff coming out these days that will allow you to get better use of the the hardware you're paying for. So one thing that I've been really inspired by is Marathon. Marathon will allow you to run long-running tasks on Mesos, and it has a nice REST API, so you could hook it into things like this. And yeah, it basically just takes all the boxes that you have, pulls all the CPU, all the RAM, and then places your microservices anywhere in that whole like aggregated pool, and it can span regions, availability zones, data centers, whatever you want, and it won't like overload one. It will spread them out nicely. So if you find yourself running like thousands of servers, and this is just not great utilization for your use case, you could look at something like Marathon. And I actually got most of this working in Marathon, but I felt like it wasn't like 100% production grade. They've made some awesome changes in the past, like a couple months that make it probably more viable than it was when I was doing this stuff before. So yeah, definitely keep an eye on it. I think it's super cool. They're doing really cool stuff. Yeah, but we added a couple of new dependencies here. So of course, there's going to be new points of failure. We're using a chef server. If that thing goes down, you're not going to be able to pull the cookbooks, and your deploys aren't going to happen until that comes back up. So that's a point of failure. We can address that. We use a private repo for Docker Hub. If that thing goes down, then yeah, you're not going to be able to pull the image if you're trying to spin a brand new thing up, or you're trying to push updates to your Docker file. So yeah, GitHub. I'm sure many of us have experienced this already. If GitHub goes down, you can't pull the latest code. So you're going to experience like points of failure with the third-party systems that you don't control. So, of course, there's trade-offs. You don't have to run your own registry, chef server, Git server, but you're sort of at the mercy of their uptime too. So, some of you may be thinking, is this totally over-engineered? I mean, there's lots of stuff out there that does pretty much the same thing. Elastic Beanstalk, OpsWorks, EC2 container service. There's new, really exciting ones popping up all the time. Google Container Engine works with Docker and Kubernetes. Yeah, as I mentioned, Marathon. So why didn't we just use one of the things that might have already existed and saved all this heartbreak? Well, actually, we did evaluate, we spec'd out like small implementations, generally working implementations of all of them and tried it. And, there was like pros and cons to all of them. Yeah, as Lucas mentioned before, like Elastic Beanstalk and OpsWorks. I can't remember he said it was like, quirky and weird. I can't remember the poetic terms that were used, but yeah, it didn't really like seem like it would work really well for our use case, especially given just like our particular stack and how it's laid out. Who knows? If it works for you, that's awesome. So I would say if you can just leverage something else, go for that first. Focus on getting your app containerized, and then just use one of these things, and then you can always roll your own later and integrate it however you need to, when that time comes. So yeah, that's all I want to really share. Happy hacking. Hope everybody, took something from this presentation, inspiration, whatever. Feel free to hit me up. Adam Meghji on Twitter, adam@universe.com. Always happy to talk about this stuff. If anyone has any criticisms of when I'm presenting, love to hear. That's awesome. If anyone has any questions or needs some help with anything, if you're hacking on stuff, let me know. Glad to have it. Yeah, any questions? Yes.
You mentioned microservices a bunch of times.
Yeah.
Have you played around with any of the Netflix open source or any other microservice frameworks?
Yeah, totally. At that scale, there's a lot of really, really cool stuff happening. There's a lot of really impressive contributions that those companies have given back. So yeah, props to them for doing it. One thing I mentioned, I was hacking on the Marathon stuff. Because I want everything to be self-healing and scaling and blah, 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 blah. And because Marathon uses Zookeeper, at one point, Netflix has a project called Exhibitor. Exhibitor. It's called Exhibitor. Basically, it's like Zookeeper plus, decentralized, discovery and all these things. So yeah, there's really cool stuff happening there. I don't think that it's as mission critical for us at our current scale, but it was cool to check it out. And yeah, it was inspiring. So there's stuff, things from exploring that were woven back into this, but yeah.
So one other question.
Sure.
Have you guys played around a little bit with how you match people to microservices? I hear, anything from one person from microservice to
Yeah, sure. So, the question was how do we align, people like staff, team, developers, contributors in the company to the microservices? I mean, inevitably, what happens is, microservices, they start out, pretty focused and small, and generally just one person cranks out a new microservice for the thing that they're working on. That's cool. And then, inevitably it grows, and more people jump on. People are supporting it. Yeah. So, to answer the question, at first it's usually one person, then someone else will jump on, maybe even just take over the ownership of it. There's always usually one or two people that are the go-to people for a particular portion of the stack, but everyone inevitably has familiarity with running it and what's going on. So we definitely, we want everyone to be aware of what's going on under the hood so they can, debug stuff. And I would say everybody eventually touches on some aspect of everything in the stack. Plus, we're all polyglot programmers and we enjoy the challenge of being inspired by different languages and frameworks too. Yes?
When do you decide you need a new microservice? Do you have a formula?
Yeah, sure. Well, I mean, we do have what we call, the core API, which is sort of the monolithic microservice. That's a Rails app. At one point we just had one gigantic Rails app and we needed an API, and then that kind of all these a lot of things kind of ended up getting built on the core API first, like recommendations, right? That was a thing we just did in Rails, and once it wasn't fast enough, didn't scale, or wasn't a great choice of language for the job, we spun that off, did it in Python, and made it its own separate thing. So really, this comes down to necessity. I mean, we're a startup, we want to move quickly, so we do what's efficient, pragmatic up front, and then we just like try and carve it off later when it's appropriate. Yes. Chef deploy? No, I haven't. No, I'll check it out. What does it do? Cool. Cool. That's awesome. Interesting. Yeah, that sounds like it'd be good. I mean, instead of like, it's kind of weird to pull in Ansible just to farm out, like just to broadcast commands to kick off a pull. So it probably sounds like it makes more sense just to keep it under the Chef umbrella and use Chef deploy then to pull the things instead of pushing a thing that pulls things. Anyone else? Steve? Cool. Thanks, guys. Really appreciate it. Thank you so much. I'll be just chilling. Let me know if you have any questions.
So before we wrap up, I have a few other orders of business that either arose or I forgot about. Mostly I forgot about. So I have a trip to Vancouver coming up for the month of June. I'm going to be away for the month of June, which is fortunate timing because I'm going to have Eric Levinson from Uberflip joining as a regular organizer. So if you're not familiar with Eric, that's Eric over there. He's waving his hand while everyone watches. And he's going to help me organize meetups after DevopsTO. So there's probably not going to be a meetup besides DevopsTO in May. But I'm going to hand it over to Eric to organize for June. And it shouldn't be hard. If it's too challenging, just set the topic to Docker and it'll all just take care of itself.
It's too challenging.
That's the only advice.
Set everything on fire.
Yeah, it's the Konami code for meetups. Another item I wanted to mention is I actually have a new job. So I just want to share this because I'm going to be sharing my experiences and my engineering work. But I'm joining a little company called StatFlow. They do customer experience management in the wireless world. So everyone who hates dealing with wireless carriers, this is my new mission. So I'm joining a 5-person incubated, previously stealth company out of 111 Richmond, and I'll be telling you guys more about that as time goes on. But for now, that's what I'm switching gears into. So I'll share my experiences as we go. I've got a lot of engineering challenges. I'll be in touch with all of you, trying to get help with everything that we're working with. So yeah, so I'm excited about that. And also, Andrew wanted me to mention that SoftLayer has a new Docker service that they're providing 3 months of free service for. So if you're interested in giving Docker at cloud scale a spin, feel free to talk to Andrew. I'm sure he's got more info about it. Did you want to say anything about it?
It comes with embedded monitoring for free and logging with help. If you want to try it, it's in beta. So
yeah, anyone who hasn't heard of Bluemix, it's amazing. You can spin up like Watson instances, right? So it's pretty incredible. Get Watson to tell you what to eat for breakfast or whatever. So that's it. One final round of applause for Uken. This is amazing. What a great space. I think we tested the temperature limit in here by having so many people. Definitely broke some fire code regulations, so congratulations for still being here. We didn't get kicked out. I'm not sure when we are getting kicked out, but I'm sure we have a few minutes to socialize, and so yeah, hang out. We might not have any beer left, but that just means we did a good job. Cheers, everybody. Thanks for coming.
Good job. Yeah. Good. Oh, a lot of people there.